How did Equipmake develop a world-leading electric drivetrain and build a £400 million sales pipeline and grow from 15 to 75 employees and float their business on the London Stock Exchange? Well, by applying for and winning an Advanced Propulsion Centre grant, obviously. Equipmake developed the motor and inverter for the APC-funded Ariel electric hypercar. That engineering work provided the blueprint for a similar but bigger best-in-class motor for the bus market, which Equipmake are now selling around the world. My name is David James, and this is the Road to Net Zero podcast, brought to you by the Advanced Propulsion Centre. For this episode, we went to Equipmake's production facility in Norwich to speak with founder and CEO Ian Foley to find out more about their incredible success.
So Ian, just tell me about Equipmake as a company.
So we develop complete electric drivetrains, vertically integrated. So we develop everything from the motor, inverter, battery pack, software, etc. for automotive and aerospace.
So what kind of customers do you have?
So our customers are one of the leading electric supercar manufacturers. Bus operators are buying our bus systems for retrofit buses. So they're the kind of companies we supply.
Now you've been doing some projects with the Advanced Propulsion Centre. Just tell us a little bit about those.
Yeah, we've had a couple of major projects with the APC. One is the Hypercar project, where we developed a motor and inverter for an electric hypercar together with Ariel. On the back of that, we won a contract with a major European electric supercar manufacturer for the inverter that we're in production with. And then on the bus side, we developed a complete electric bus drivetrain under the Celeb project, which again we're now in production with.
Now there's lots of people that build motors, inverters, battery packs, drivetrains. What's different about Equipmake?
So the major difference with us is we are completely vertically integrated. So for example, for the bus project, we design and manufacture all of the key components. This means we can get better integration. For the bus, for example, it's really crucial that the heating and cooling system is fully integrated with the rest of the system for efficiency. So we can deliver a much more integrated, efficient solution because we are vertically integrated.
And what difference does that make to a customer?
So that means that the system is ultimately lower cost. We only have to make a margin once. So we're competing with people who are buying in motors, battery packs, inverters, integrating them into a system and reselling. We're doing everything. We only have to make a margin once. And then, for example, with the HVAC, the heating and cooling, the fact that that is integrated makes it more efficient. That saves battery capacity. That makes the system lower cost.
So around the world, there's lots of businesses investing huge amounts of money in electric vehicles, electric drivetrains. Where do you think the UK and small and medium-sized enterprises like yourself can fit into this globally very competitive market?
So where I think we fit, and particularly something like the bus market or the niche vehicle market, where they are huge markets for us, but very small for the major manufacturers. The major incumbents at the moment are struggling with a declining diesel business. They need to maintain that business while they develop new technology. We can be more nimble. We can develop the product more quickly, get it to market more quickly. And in these markets, such as bus, where everybody wants something different, that gives us a particular advantage.
In terms of R&D, it does feel like places like Germany, Japan, China are putting a lot of money in, but Britain's got a long history of some of the best innovation. Do you think that helps?
I think it definitely helps. We have Japanese investors. I mean, they invested in us because they said, actually, companies like us don't really exist in Japan. It's the kind of culture that exists here is different. It's something which I think is unique to the UK, which is why we have so many of these innovative small companies.
How has the support of Advanced Propulsion Centre accelerated your progress as a business? What have you been able to achieve that you wouldn't have been able to otherwise?
So the APC projects have been crucial to us. We've had two major projects we've mentioned, Hypercar and the Celeb bus project. Particularly with the Celeb project, the money that we got from the Advanced Propulsion Centre, we could match them with Japanese investment, early stage investment. That enabled us to get a product which enabled us to win contracts from a major UK bus operator. On the back of that in our pipeline, we now currently have a pipeline of £400 million worth of potential orders, and that has enabled us to go to the stock market and float the business. So basically, when we started with our APC funding, we had 15 people and we were a very small company. At the end of the APC funding, we're a listed company with 75 people.
So you've talked about one sale, one potential opportunity at 400 million. What's the turnover? What's the turnover look like with the import of the APC funded?
So the 400 million mentioned is actually a pipeline of business over multiple, mainly potential bus contracts. 2 weeks ago, I was in Indonesia. We've just signed an MOU with Transjakarta. That's the Indonesian or Jakarta equivalent to Transport for London. We've got an MOU with those guys. They need 10,000 electric buses by 2030. We're about to trial a bus for Transport for London in the UK. So we've got multiple of these potential opportunities that all add up to the 400 million. We are planning to grow. We're currently working through a 10 million order book. We're planning to grow to 250 million in the next 5 years.
So let's get into a bit more detail with the two projects. Let's start with the Hypercar. It's a very exciting project to be on. It's Ariel's a company that really attracted the most ardent petrol heads, and now they're going electric. Just talk about some of the technology you've developed. What's special about it?
Yeah, so what we developed was a very lightweight combined motor, inverter and gearbox. So on each corner of the car for a four-wheel drive car, there's a unit which connects directly to the drive shaft. It's very lightweight, which is crucial. Again, Ariel make the lightest weight, highest performance vehicles. And so we are part, with that consortium, we've been able to produce a car which is a very, very lightweight electric hypercar, giving very high performance.
What difference do you think it made, rather than just building a family EV or just a regular road-going EV, what difference did it make to your learning as a business to push it to its extremes?
Yeah, so I think doing something like the electric hypercar, it's similar to, a number of us in the business come from a motor racing background. It's a similar philosophy. When you push things right to the limit, I think for the last few percent, things get a lot more difficult. So in solving those problems, you end up with a much better product that actually then transfers to the core product. So we end up with a better control system. Response times need to be faster. So the software is developed to a much higher level. Light weighting makes it a more extreme mechanical design. And once you've perfected that for something like an electric hypercar, those lessons result in a better performance in the mainstream product. So for example, our motor we developed for bus is about half the weight of the main competitor motor in the bus field. It's significantly lighter. Now it's a heavier overall product. The bus motor is 200 kilos and the hypercar motor is 40 kilos, but the bus motor is half the weight of the competitor motor.
You've already answered it really, but the next question is, was public money going funding into these niche high performance, low volume projects? And I guess the answer you've given us already really is about the learning then moves into mainstream products.
In terms of speed to market with something like a hypercar, we can get to market quicker with that product. But with what we learned, that's led directly to our bus development. And now we're in the fortunate position, we're in the right place at the right time with the bus product, and we've got a huge market opportunity. We wouldn't have that opportunity if we hadn't started 2 years early with the hypercar project.
One thing I was thinking about, particularly with the hypercar project, is the UK's is the home of global motorsport engineering, really, with Formula One and other motor racing industries are based in the UK. Do you think that is something we could leverage more broadly into the EV space and become globally competitive?
I think there's certainly in training the engineers. One challenge with motorsport is because there isn't really a cost constraint, then the developments can lead down an avenue that's not 100% relevant. But I think in terms of training engineers, yes. I think one of the marvels of 20th century engineering is that conventional cars are as cheap as they are for the quality that they are. The main challenge now for EVs is to drive the cost down. The performance is great, the reliability is there, the cost is too high. And so we've now got a period of engineering cost down, which is probably going to take about another 10 years to get the costs where they need to be.
So let's talk about the Celeb bus. What I'm interested in is that you're doing this as a retrofit and for new buses. Just to explain what you've done and how you've been able to use the same technology in two completely different markets.
That's correct. Effectively, the technology is the same, whether it's new or for retrofit. The challenge with retrofitting, or repowering as we like to call it, is that because we've got to fit to an existing vehicle, we're often doing slightly different battery packs, but the core, the motor, inverter, etc. is the same. We are repackaging batteries to fit different types of vehicle. But there are so many buses. If you look in the UK's got 30,000 large buses. There just isn't the funding or time available to replace those all with new in the next 15 years. And people have now realised that. But like I say, it's not just a UK opportunity. I've just come back from Indonesia where we've got an MOU there, and there's other countries interested as well. So everybody's kind of realising that targets for zero emission vehicles are racing towards us. These vehicles with a bus typically last 15 years. So there's going to be lots of buses out there which are pretty new, which are going to need to be converted to zero emissions. So we can use exactly the same technology, slightly repackaged.
How difficult is it to repower a diesel bus? Because shoehorning new technology into something that's been designed for a completely different powertrain sounds very difficult.
It's a bit of a challenge. The main challenge really is to maintain the carrying capacity of the vehicle. The vehicle's got a maximum laden weight. In order to be commercially viable for the operator, it needs to carry the same amount of passengers. So the challenge is, how do you get particularly the batteries on the vehicle, maintain the right weight distribution and maintain passenger capacity? So that is a challenge, but we've managed to do it now on a number of different vehicles, which are all quite different buses. So it is a challenge, but the team here are quite used to doing that on a number of vehicles now.
Now, Simon from Ariel was very keen on the phrase, I'm not sure where he picked it up from, but once you've finished your design, now add lightness. Add lightness. It sounds very challenging because buses aren't light. When you look at most buses, they've not really thought about lightweighting typically when they've designed them, I don't think. What challenges have you faced and have you overcome them? Anything that you can talk about without giving away your IP?
You're right that the base vehicle, there's not a lot we can do with that. So it's really a question of us saving weight on our system. That's why, for example, because our motor is 200 kilos rather than 400 kilos, that's a significant weight saving versus the incumbent technology. So it's really, for us, it's a question of us saving weight where we can. And so far we've managed to, for a city bus, you need around 400 kilowatt hours of batteries, and we're managing in most cases to be able to package that and stay within the weight limits of the vehicle, but it is a challenge.
What kind of range can you get out of a repowered bus?
Typically, at 400 kilowatt hours of batteries, it's around 150 miles range. It does depend an awful lot on the heating system. So what's crucial on the bus is you can use as much energy to heat and cool the saloon of the vehicle as it takes to drive it along if it's very hot or very cold weather. And that's why, with us developing our own heating and cooling system that's integrated with the rest of the vehicle system, that's given us some more efficiency. But it's around 150 miles, which is enough for a typical city bus duty cycle.
Just talk about the purpose-built buses that you've partnered with. Just talk about the partnership, what buses they are, what's special about them, where they're going to get sold, etc.
Our first partnership was with Bulas of Spain, so they were very interested in the UK market. So Bulas have developed a London spec body. Because of our vertically integrated approach, with that new vehicle, we've managed to get 540 kilowatt hours of batteries, and that will give that vehicle about 250 mile range. So we've got the largest range of any UK spec double deck bus because the system's been designed into the bus from the start, and we've got a very lightweight system. And now with our Indonesian partner, we're starting there with retrofit, but again, they're developing a new bus and we'll be supplying the technology for their new bus as well.
Is there anything you're particularly proud of?
Like I say, the motor we've got is half the weight of the competitor. It's super optimized, but really it's the whole package. It's the fact that we are vertically integrated, and the fact that we've developed an integrated package is the thing which is different and makes the whole thing more efficient in terms of weight, but also in terms of the control, etc.
What next for Equipmake? What's the future looking like?
So the future looks pretty bright. So we've literally, only 4 weeks ago, we floated on the London stock market. We've got a hugely ambitious plan. So we're now supplying our inverter into European electric supercar. We're supplying into aerospace. So we're supplying one of the premier eVTOL companies. We're supplying electric motors for rocket fuel pumps for low Earth orbit satellite launches in Australia. So we've got lots of really interesting stuff going on. But our main commercial focus is in bus. We've got a huge pipeline of opportunity. We've now got the finance behind us to go off and achieve those objectives.
Now, filling in any sort of grant paperwork is always a faff. You know, if you're a business owner, you're a startup, you kind of got a million things to think about. What would you say to those people that have heard of the Advanced Propulsion Centre but haven't got round to applying for one of the projects?
So I think they definitely should. I think the APC are really helpful in terms of helping people with their applications. Clearly there's got to be a rigorous process, it's public money, but there's lots of help there. And for us, I mean, we filled in our own application, and I think the process is a process which is easily achievable for any small company.
But what about the overall benefits of getting involved with APC?
Clearly the main benefit is the funding, but also we have been introduced to other partner companies. I think there are other spin-off benefits over and above the funding, and particularly the collaborative approach means that we've met with people that we wouldn't have met with had we not been part of the APC.
Ian, thank you very much for your time.
Thank you very much.
Thank you for taking the time to listen to this episode of The Road to Net Zero. To find out more about how the Advanced Propulsion Centre is helping the United Kingdom accelerate low-carbon vehicle technology, visit apcuk.co.uk.